Now let's talk about the cross product. If you have two vectors a and b as in previous slide, and our vectors are expressed through the following: a equals axi plus ayj plus azk, and b equals bxi plus byj plus bzk, where ax and bx are the x components, ay and by are the y components, az and bz are the z components. We can calculate our cross product using this expression, where we have the determinant, and the elements of our determinant are I, j, k, ax, ay, az, and bx, by, bz. The result of our cross product will be a vector, so the answer will be in vector format using the unit vectors I, j, and k. Now let's talk how to calculate the determinant. So if we want to calculate determinants, we can use several methods, and one of them is presented here. So if we want to calculate our cross product, we can repeat our first two columns, which are I, 3, 2, and j minus 5, 4, to the left from our determinant, and then we will use diagonals. So our summing diagonal will be oriented from upper left corner to bottom right corner, and if we have this diagonal, we multiply all the elements on this diagonal. So we calculate our determinant and we use this diagonal. It means we multiply I minus 5 and minus 7. Then we use our second summing diagonal. So we multiply j by 8 by 2, and then we use our third summing diagonal. So we add the multiplication of k and 3 and 4, and now we will use our subtracting diagonals. So our subtracting diagonal is diagonal oriented from upper right corner to bottom left corner, and we subtract, so we have minus k times minus 5 times 2. Then we subtract our second subtracting diagonal, and this will be minus I times 8 times 4, and minus our third diagonal, which is j times 3 times minus 7. So finally our cross product of a and b will be like that, and then after simplifications we have the result, which is 3i plus 37j plus 22k, and our result is the vector with I and j and k. So our final answer is represented in vector form. If our vectors are given graphically, as in previous case with scalar product, so we know the location of the vectors, we know the magnitudes of the vectors, and we know the angle between them, we can use the following formula to calculate cross product. So our cross product of AB equals multiplication of the magnitudes of A and B and sine theta, where theta is the angle between the vectors A and B. And we know that the result of cross product is a vector, so our vector will be always perpendicular to the plane organized by our two original vectors, and its orientation will depend on the location of the vectors a and b. So this is so-called a right-hand rule. So here in this diagram we can see that our resulting vector is oriented upward, but if we interchange our vectors a and b, our resulting vector will be oriented downward. Now let's look at some interesting facts about dot product and cross product. So if we take our dot product, and if we want to interchange our vectors a and b, the results will be the same. So our dot product of a and b equals dot product of b and a. But if we take our cross product, our result, which is the vector, will have the opposite direction. So our cross product of a and b will be equal to minus cross product of b and a. Let's look at another interesting formula. So this is so-called Lagrange's formula, and here we can see that our cross product of a and the cross product of b and c is equal to the dot product of b and dot product of a and c minus dot product of c and dot product of a and b. So if we take these vectors a, b and c, which are equal to 2i minus 3j plus k and minus I plus j plus 3k and I plus 2j and minus k, we can check this formula, and let's start with the left hand side of this expression. So we want to calculate the cross product of a and the cross product of b and c, and first let's calculate the cross product of b and c. So this cross product equals to this determinant ijk minus 1 1 3 1 2 minus 1, which is equal to minus 7i plus 2j minus 3k. And if we want to organize our final determinant, we'll have the coordinates of the vector a, which are 2 minus 3 1, and the coordinate of the vector obtained using the cross product of b and c, which is minus 7 2 and minus 3, and the result will be 7i minus j minus 17k. Now let's calculate our right hand side. So before the calculation, let's calculate the dot product of a and c and a and b. So the dot product of a and c is the sum of multiplication of corresponding coefficients at I and j and k, which are 2 times 1 plus minus 3 times 2 plus 1 times minus 1, and finally we obtain this minus 5. The same procedure for dot product of a and b, and we obtain minus 2. So finally, if we want to calculate our right hand side, we multiply vector b, which is minus I plus j plus 3k, by this minus 5, then minus our vector c, which is I plus 2j minus k, and we multiplied by obtained minus 2, and finally this will be equal to 7I minus j minus 17k. So we can see that the results for our left hand side and right hand side are the same, so we just prove this formula. Thank you for attention. I hope you will enjoy the vectors. Bye bye.